Welcome everyone to this live podcast on Twitch, where you can find the news from the research industry that how our researcher keep on researching on various topics and domains as, to keep our lifestyle better and useful, of course. And yes, and this article posted on our website named postscientist.com. So if you are willing to check it out, please check it out. Otherwise, listening to this podcast will be enough for you guys, as it acts like an archive on the daily basis, providing you the information from the research industry. So let's get started without wasting any further time. The first topic of the day is new tool allows scientists to peer inside neutron stars. Hmm. Ima- Imagine taking a star twice the mass of the sun and crushing it to the size of Manhattan. The result would be a neutron star, one of the densest objects found anywhere in the universe, exceeding the density of any material found naturally on Earth by a factor of 10 of trillions. Neutron stars are extraordinary astrophysical objects in their own right, but their extreme densities might also allow them to function as laboratories for studying fundamental questions of nuclear physics under conditions that could never be reproduced on Earth. Because of their exotic conditions, scientists still do not understand what exactly neutron stars themselves are made from. Their so called equation of state EOS, determining this is a major goal of modern astrophysics research. A new piece of the puzzle constraining the range of possibility has been discovered by a pair of scholars at IAS, Caroline Rethel, John and Backel, fellow in the School of Natural Science, and Elias Mosh, member in the school, and John A. Wheeler, fellow at Princeton University. Their work was recently published in the Astrophysical Journal Letters. Ideally, scientists would like to peek inside these exotic objects, but they are too small and distant to be imaged. With standard telescopes, scientists rely instead on direct properties that they can measure, like the mass and radius of a neutron star, of course, to calculate the EOS. Yes. The same way that one might use the length of two sides of right angle triangle to work out its hypotenuse. However, the radius of a neutron star is very difficult to measure precisely. One promising alternative for future observation is to instead use a quantity called the peak spectral frequency, or F2, in its place. But how is F2 measured? Collision between neutron stars, which are governed by the laws of Einstein's theory of relativity, lead to strong bursts of gravitational wave emission. In 2017, scientists directly measured such emission for the first time. At least in principle, the peak spectral frequency can be calculated from the gravitational wave signal emitted by the wobbling remnant of two merged neutron stars, says Moose. It was previously expected that F2 would be a reasonable proxy for radius, since until now researchers believed that a direct or a quasi-universal correspondence existed between them. However, Rethel and most all have demonstrated that this is not always true. They have shown that determining the EOS is not like solving a simple hypotenuse problem. Instead, it is more akin to calculating the longest side of an irregular triangle, where one also need a third piece of information, the angle between the two short sides. For Rethel and Mosh, this third piece of information is the slope of the mass radius relation, which encodes information about the EOS at higher densities and thus more extreme conditions thus than the radius alone. This new finding will allow researchers working with the next generation of gravitational wave observatories, the successor to the currently operating LIGO, to better utilize the data obtained following neutron star mergers. According to Rethel, this data could reveal the fundamental constituents of neutron star matter. Some theoretical predictions suggest that within neutron star cores, phase transition could be dissolving the neutrons into subatomic particles called quarks, stated Rethel. This would mean that the stars contain a of free quark matter in their mirrors, in their interiors. Our work may help tomorrow researcher determine whether such a phase transition actually occurred. So these are the, I mean, finding studies given by our scientists about the new tool uh, allow scientists to peer inside into the neutron star itself. So yep. uh, and yes, it's been well described by the author itself, so no need any explanation by my side. So let's get into another article. Study finds California greenhouse gas reduction could be wiped out by 2020 wildfires. Okay, interesting. A new analysis led by researchers with the University of California has found the 2020 wildfires in the state the most disastrous wildfire year on record, put twice as much greenhouse gas emission into the Earth's atmosphere as the total reduction in such pollutants in California between 2003 to 2019. Wildfires in California have become a major and growing source of GHG emission, said Dr. Mikhail Jarrett Ukla, Fielding School of Public Health professor of environmental health science and a lead author of the research. Wildfire emission in 2020 essentially negate 18 years of reduction in greenhouse gas emission. The research up in smoke California greenhouse gas reduction could be wiped out by 2020 wildfire is published in the October edition of the journal Environmental Pollution. Jared co-authored, who include researchers from UCLA and the University of Chicago, found a California wildfire carbon dioxide equivalent or CO2 emissions from the 2020 blaze are approximately two times higher than California total greenhouse emission reduction since 2003. To the great credit of the California policymaker and residents, from 2003 to 2019, California GHG emission declined by 65 million metric ton of pollutants, a 13% drop that was largely driven by reduction from the electric power generation sector, said Jared, who also serves as co-director of the UCLA Center for Health Climate Solution, Solution, a research center focused on protecting people and communities from the effects of climate change. Essentially, the positive impact of all that hard work over almost 2 decades is at risk of being swept aside by the smoke produced in a single year of record breaking wildfires. Over the long to very long term, regrowth of vegetation is burned areas could elevate some of the emission but will not occur quickly enough to avert highly dangerous level of increased pollution, temperature and climate change, the researcher said. To put this into perspective, without considering future vegetation regrowth, emission from the 2020 wildfires could be the second most important source of GHG emission in the state of California, above either industry or electrical power generation, said Dr. Mariam Marlier, a UCLA Fielding School professor and co-author. It's worth noting that many of the worst fires years in California history have occurred in the past 20 years, with 18 of the top 20 most destructive fires in terms of loss of life and property since 2005 in 2020 alone. The researcher also examined the financial cost of the wildfire derived air pollution based on different criteria. The carbon emission only damages for California alone are approximately 98.7 million for the United States and some $986.9 million dollars, and globally as much as $7 billion dollars. These are estimates, of course, but they represent a current unquantified aspects of damages due to fire that are incurred globally in the US and in California itself, said Dr. Amir Jinnah, an assistant professor at the University of Chicago Harris School of Public Policy and a co-author of the research. These damages should be counted in addition to fire control cost, damages to health from air pollution, and direct loss of life and property. Historically, California summer wildfire burned area increased eightfold from 1972 to 2018, and statewide climate change projections suggest increased wildfire risk due to higher temperature and drier conditions. Climate change exacerbates fire risk already stoked by increasing development near the wildland urban interface WUI, as well as decades of fire suppression and underinvestment in preventive measures including mechanical clearing or prescribed burns. Wildfires in turn release GHG emission that can contribute to climate change. Although wildfires are natural features of many ecosystems in California, the increase in severe and frequent wildfire events has raised the possibility of transformed post-fire ecosystems. Mildly said, even if long-term regrowth occurs, however, the carbon emission occurring in the next 15 to 20 years will make it difficult to reach emission reduction targets needed to avoid the increases in mean global temperature advocated by the Intergovernmental Panel on Climate Change or IPCC. The challenge of understanding these very complex systems and finding policy options that can help find solution is at the core of the research. Jared said wildfire emissions have not received nearly the same level of the investment or attention or GHG emission from other sectors. He said although wildfires are to some extent natural occurrence, human activity contributes to making wildfires unnatural disaster through man-made climate change and development at the WUI in fire prone areas, and every Californian can understand the potential cost, of course. Moving on towards next topic. Deep learning tool identifies bacteria in micrographs. Omnipose, a deep learning software, is helping to solve the challenge of identifying varied and minuscule bacteria in microscopy images. It has gone beyond the initial goal to identify several other types of tiny objects in micrographs. The UW, the yes, the UW Medicine Microbiology Lab of Joseph Mogles and the University of Washington Physics and Bioengineering Lab of Paul A. Wingson tested the tool. It was developed by the University of Washington Physics graduate student Kevin J. Cutler and his team. Morgus said that Cutler, as a physics student, demonstrated an unusual interest in immersing himself in a biology environment so that he could learn firsthand about problems in need of solution in this field. He came over to my lab and quickly found one that he solved in spectacular fashion. The results are reported in the October 17th edition of Nature Methods. The scientists found that Omnipose, trained on a large database of bacterial images, performed well in characterizing and quantifying the myriad of bacteria in mixed microbial cultures and eliminated some of the errors that can occur in its predecessors, Cellpose. Moreover, the software wasn't easily folded by extreme changes in a cell shape due to antibiotic treatment or antagonism by chemical produced during interbacterial aggression. In fact, the problem sorry The program showed that it could even detect cell intoxication in a trial used E. coli. In addition, Omnipus did well in overcoming recognition problems due to difference differences in the optical characteristics across diverse bacteria. Most bacteria are spheres or rods. Some have other basic forms such as twisting spirals. Besides this, Omnipus could identify more elaborate bacteria with elongated shapes or with branches, filaments, and appendages, all physical traits that can make it difficult for deep learning tools to suss out which bacteria are present in an image. The program does still face some limitation in handling object overlap in a 2D rendition of a 3D sample of a crowded microbial community. Object overlap is what produces, for example, the effect of a clock on a wall, giving the illusion of popping out of a person's head in a photograph. In analyzing cells in a root primordial dataset from the fast growing weed A. Thaliana, Omnipose nonetheless did show some advantage over previous approaches in this 3D sample. Other reviews of the Mogus lab team of Omnipose capability showed bacteria below a certain threshold in size can be hard for the tool to suss out. Despite these drawbacks, the researchers believe that Omnipose could be a solution they noted to help answer diverse questions in bacterial cell biology. To see if it could be also become a multifunctional tool in other biological or even non-life sciences field dependent on microscopy, the scientists tried out the program on micrographs of the ultra tiny roundworm C. elegans, an important organism in genetic neuroscience development and microbial behavior research. Like some bacteria, this creature has an elongated shape like many other worms. It also can contort itself. Omnipose could pick out C. elegans regardless of its various stretches, contraction, and other movements. This ability could be useful, for instance, in neural study of C. elegans, locomotion during time lapse, tracking, and designing tool like Omnipose. Researchers are looking at a scale of single pixel precision to define the boundaries of a cell. That's because most bacterial cell body images are composed of only a small number of pixels. The researcher explained that defining boundaries within an image is called segmentation. They developed Omnipose through a deep neural network, high precision segmentation algorithm. Their experiment showed Omnipose has an unprecedented segmentation accuracy. The scientists uh, designed Omnipose for use by typical research laboratories and made its source code, training data, and model publicly available along with documentation and on how to use the program. Okay. We anticipate that the high performance of Omnipose across varied cellular morphologies and modalities. The researcher wrote in the report may unblock information from microscopy images that were previously inaccessible, reflecting the importance of the problem. This is Crowdfield Morgus said, yet Kevin's solution stands out from the pack. We believe it will be a game changer for biological image analysis. So these are the study. These are the, I mean, not the study. It's a deep learning project which will it's provided by by our software engineers, or yep, because and the scientists, of course. So yeah, I mean, what we call them, neuro researcher or neuroscientist. I mean, because it's a deep learning project or a tool which identifies the bacteria in the cell. So yeah, I mean, okay. Moving on towards next topic. New analysis of obsidian blades reveals dynamic Neolithic social networks. Okay. An analysis of obsidian artifact excavated during the 1960s at two prominent archaeological sites in southwestern Iran suggest that the networks Neolithic people formed in the region as they developed a- agriculture and larger and more complex than previously believed. According to a new study by Yale researchers, the study published October 17 in the journal Proceeding of the National Academy of Science is the first to apply state of the art analytical tools to a collection of two 2100 obsidian artifacts housed at the Yale Peabody Museum. The artifacts were unearthed and more than 50 years ago at Ali Kosh and Changla Safed sites on Iran De Luran plain that yielded important archaeological discoveries from the Neolithic era, the period beginning about 12,000 years ago, when people began farming, domesticating animals, and establishing permanent settlements. Original analysis performed shortly after the artifacts were discovered had suggested people first acquired the obsidian volcanic glass from a Nemrut Dag, a now dormant volcano in eastern Turkey, and then relied on an unknown second source for the material. This new element analysis showed the obsidian came from seven distant sources, including Nemrut Dag in present day Turkey and Armenia, which is as far as about 1000 miles on foot from the excavation sites. It wasn't a simple pattern of people obtaining obsidian from one source and then shifting to the next, said Elliot Fram, an archaeological scientist in the Department of Anthropology in Yale's Faculty of Arts and Sciences and the study lead author. That the art analysis shows that they were acquiring obsidian from an increasing diverse number of geological sources over time, a trend that was impossible to detect with the technology and methods available 50 years ago. Hmm. The new okay. The new analysis combined with computer modeling indicate that they were intensifying connection among Neolithic people, suggesting the presence of a great number of settlements between the source volcanoes and the two sites where the artifacts were unearthed. Thousands of years later, Farham said the artifacts were collected in the 1960s during multiple excavations of the two sites led by Frank Hole, the C.G. McCurdy Professor Emeritus of Anthropology at Yale. The initial analysis were based largely on the artifact's appearance, specifically the color when held up to sunlight. A subset of 28 artifacts were then subjected to an environmental analysis method common at the time that involved grinding them into powder. Fram and co-author Christian M. Carlos, a doctoral student in the Department of Anthropology, are the first researchers to study the elemental composition of the obsidian artifacts since this early analysis. They use our state of the art portable X ray fluorescence instruments, which allowed them to examine the entire collection without damaging the artifacts. Every aspect of the discovery made at these sites had been revisited since the 1960s, expected the elemental composition and sourcing of the obsidian artifacts. Kerala said a lot more is known about the source volcanoes today than 50 years ago, and we know that sorting obsidian by color will miss a lot of nuance. Fortunately, we have instrument the size of cordless drills that, in a matter of seconds and without destroying material, give us a more accurate elemental signature than anything that was possible in the past. Scientists widely believe that humanity transition from the hunter-gatherer lifestyle to agriculture produced a period of rapid population growth due to increased birth rates made possible by enhanced food supplies and permanent settlement. Finding evidence of this demographic shift often requires excavating locations that include burial sites, which can indicate a given settlement population and provide a clear picture of how agriculture allowed people to disperse across the landscape. Farham said the researcher analysis of the obsidian provided similar evidences, tracing these obsidian artifacts from their sources to the to their endpoints, offered insight into how they moved from hand to hand over time, which help us better understand population changes in the region during the Neolithic era. Ferrum said it suggested there were larger social networks and more settlement between the source volcanoes and the excavation sites than we previously thought. I mean, great man, great finding, great uh, research on this. Okay, moving on towards next topic. New MRI technique could allow for non-invasively tracking propagation of brain signals on millisecond timescales. A team of researchers affiliated with multiple institutions in the Republic of Korea has developed a new way to use a magnetic resonance imaging MRI for non-invasive tracking of the propagation of brain signals on millisecond timescales. In the paper published in the journal Science, the group described how they developed the new technology, its features, and how well it worked when tested on mice. Timo Van Krekolle and Mart Jen Close with University of Paris Clare and the University of Queensland respectively have published a perspective piece in the same journal issue outlining the work done by the team of this new effort. MRI works by sending magnetic field along with radio waves through tissue to produce images of the tissue under study. It works because different types of tissue have different properties. MRI is also used in different ways depending on the part of the body under study. Blood oxygen level dependent functional MRI is used to obtain images of the brain of a living person. The technique allows for observing changes in blood flow in the brain that serve as a stand for an increase in neuronal activity. In practice, blood oxygen level dependent functional MRI produces multiple image over time, generally over several seconds. In this new effort, the researchers have modified the way an MRI brain scan is performed. The new technique called direct imaging of neural activity (DINA) works by modifying a traditional MRI machine to create images faster on the millisecond scale, potentially at the speed of the thought. It does so by creating partial images that are combined afterward to create a high resolution image that represents an instant of brain activity. After a single scan, multiple high resolution images are created that show that the state of the brain as it responds to a stimulus, such as jolt of electricity applied to the whiskers of test mice. By generating images so quickly, the technique allows researchers to observe the propagation of the brain signal from one part of the brain to another in a non-invasive manner. The new technique has thus far only been tested in mice, but the researchers are already calling it a game changer, suggesting it could transform the way of the scientists study the brain and could lead to a new understanding of how it works. I mean, it's great for the doctors and the neuro research and neuroscientists. So, yep. Moving on towards next topic, exploring the decay processes of a quantum state weakly coupled to finite size reservoir. In a quantum physics, Fermi golden rule, also known as golden rule of time independent permutation theory, is a formula that can be used to calculate the rate at which an initial quantum state transition into a final state, which is composed of a quantum of states, a so-called bath. This valuable equation has been applied to numerous physics problems, particularly those for which it is important to consider how systems respond to imposed perturbations and settle into stationary states over time. Fermi golden rule specifically applies to instances in which an initial quantum state is weakly coupled to a quantum of other final states which overlap its energy. Researcher at the Center Brasileiro de Pesqueiras Physics, Princeton University, and Universidade Zhu Colon have recently set out to investigate what happens when a quantum state is instead coupled to a set or discrete final state with a non-zero mean level escaping as observed in recent many body physics studies. The decay of a quantum state into some content of final state, that is a bath, is commonly associated with incoherent decay processes are described by forming golden rule. Tobias Milskits, one of the researchers who carried out the study, told physics.org, a standard example for this is an excited atom emitting a photon into an infinite vacuum. Current data experimentation, on the other hand, routinely relies composite system involving quantum states coupled to effectively finite size reservoirs that are composed of discrete sets of final states rather than a continuum. While several past studies have identified systems in which quantum states are coupled to finite size reservoirs, understanding the condition under which this happens, allowing the finite size reservoir to effectively act as bars, is a challenging task. The key objective of the recent work by Miskits and his colleagues was to better understand the process through which a quantum state decays when coupled to a finite size reservoir. Our starting point was to consider generic finite size reservoir lacking any specific symmetries. Miskits explained. Such systems usually show quantum chaotic behavior and can be modeled by random matrix for which powerful analytical tools are available. To carry out the analysis, Miklitz and his colleagues used a combination of effective matrix integral technique, which are commonly used in studies applying random matrix theory, a theory that summarizes the different properties of matrices with entries drawn randomly from different probability distribution to benchmark the result of their analysis. They then use exact diagonalization, a powerful numerical technique often used by physicists to study individual quantum many-body systems. Initially, we hadn't expected the decay into a finite-sized reservoir to be described by such a complex time dependence. Mixer said, we found that the probability to reside in the weakly coupled level shows a non-monotonous time dependence with initial decay followed by a raise before saturating to a constant value. The temporal profile follows in a large regime of parameters. The spectral form factor, a well studied object in the quantum chaos community, which encodes information on energy level correlation in the reservoir. This makes much sense in the retrospective perspective. Now published in the Physical Review Letters, the recent study by this team of researchers offers a fully analytic description of a crucial and fundamental physics problem. More specifically, it offers a connection between the problem of how a quantum state decays into a set of discrete final states to the states associated with energy levels and wave function in chaotic quantum systems. We relate the temporal profile of the probability of residence to the spectral form factor in the ratio of the probability minimum and saturation value to the state of reservoir eigenfunctions. Mixlers added our work focus on fundamental but also rather elementary example of relaxation into a finite size reservoir. We are now trying to address more complex systems such as ensembles of spins coupled to a quantum dot. Hopefully, progress can be made using similar methods as they employed in our recent paper. Okay, moving on to our next topic. Many of you thinking that I'm not explaining it or I'm not able to understand it, but it's not. That's not the case because I mean we have to cover lots of articles, due to which I'm focusing on to covering those articles in the podcast um, frequently, so it's being provided to you. No, not because I'm get into those articles and explain each and everything. So, and yes, of course, it's well described by author herself. So, I mean, there is no need for explanation by my side. But if you want, please comment me down. I will explain in every broadcast for the description or having a short summary of an article provided to you. So, yep. Making a case for femtophonomagnetism in ultra fast times. Magnetic matter can be regulated by ultra-fast laser pulse in the field of ferromagnetism. In a new report now published in Science Advances, Sangeeta Sharma and a team of scientists and the Max Planck Institute in Germany developed a powerful new method to facilitate magnetic order at ultra-fast times by coupling phonon excitation of the nuclei to spin and charge to create femtophonomagnetism. The team used state-of-the-art theoretical simulation of coupled spin, charge, and lattice dynamics to identify non-adiabatic spin phonon coupled models which dominated the early time spin dynamics. The findings showed by physicists and material scientists can selectively pre-excite the nuclear system to regulate the femtosecond spin dynamic in material, storing information via femtophonomagnetism. Information can be stored and processed at a speed determined by fundamental time scales at which external fields can influence matter. Researchers have determined the fastest such route by interacting matter with the electromagnetic field of light, wherein ultrafast lasers can regulate magnetic order as a key route to determine macroscopic order. These processes can occur via a range of methods, either by spin transfer between magnetic sublattices or by regulating spin orbit coupling. Of all processes, the lattice acts as an energy and momentum reservoir that retains the demagnetized angular momentum in this work. The team addressed the role that lattice phonon excitation play in the dynamics of the magnetic order on ultra-fast timescales. They used iron and platinum FAPT during the study to show how selective lattice excitation prior to applying the laser pulse resulted in significantly improved demagnetization. However, they used to observe a discernible change in the magnetic movement in the absence of the laser pulse. Electron phonon coupling and femtophonon magnetism. Sharma and colleagues regulated the spin dynamic via selective phonon modes and observed the phonon spectra and electron phonon coupling for the iron platinum samples. They used a double pump setup where the photons were pre-excited. Then they included an optical laser pump to regulate spins in the presence of the excited phonon modes. The team observed the spin dynamics of iron platinum under the influence of a pulse in the presence of two strongly coupled phonon modes. The in plane platinum mode had a significant effect on the spin dynamics. The result highlighted the ability to excite nuclear dynamic to influence ultrafast demagnetization for faster spin regulation. Furthermore, while large electron photon coupling is useful as a guide, it did not result in large spin phonon coupling. The researcher explored the rationale behind enhanced demagnetization resulting from non adiabatic coupled spin nuclear dynamics, that is, in which the nuclear motion was affected by more than one electronic state. They noted a flow of spin current from iron to platinum atoms for terahertz terahertz generation, a radiative effect of crucial importance which they intended to explore in the future. The researcher also expect to study light emission resulting from phonomagnetism. The key outcome of this work showed how the magnetic spin current between sublattices regulated the physics of spin phonon coupling outlook. Hmm. In this way, Sangeeta Sharma and colleagues demonstrated a multi-component magnet for information storage via femtophonomagnetism. In the study, the nuclear degree of freedom did not only function as an energy sink for pump to spin but also facilitate improved spin dynamics at femtosecond time scales. The team explored the nature of spin phonon coupling and this microscopic mechanism underlying the effect of for enhanced demagnetization. The outcome will facilitate a route toward a spin regulation via small apatite coherent phonons in multi-component metallic magnets. The scientific experts expect future study to explore the effect of such currents on light emission, where the outcome will provide a new mechanism to regulate magnetic order at a femtosecond time scale for widespread application in condensed matter physics. Hmm. So these are the study. These are the, I mean, magnetism value of the case. So yep. Moving on to our next topic, climate change may boost Arctic virus spillover risk. Okay, let's see. A warming climate could bring viruses to the Arctic into contact with new environments and hosts, increasing the risk of viral spillover. According to research published Wednesday, viruses needs hosts like humans, animal, plants, or fungi to replicate and spread, and occasionally they can jump to a new one that lacks immunity, as seen during the COVID-19 pandemic. Scientists Canada to investigate how climate change might able spillover risk by examining samples from the Arctic landscape of Lake Hazen. It is the largest lake in the world, entirely north of the Arctic Circle, and was truly unlike any other place I have been. Researcher Gadam Colby, now a medical student at University of Toronto, told AFP the team sampled soil that becomes a riverbed for melted glacier water in the summer, as well as the lake bed itself, which required clearing snow and drilling through 2 meters of ice. Even in May, when the researcher was carried out, they used ropes and a snowmobile to lift the lake sediment through almost 300 meters, 980 feet of water, and samples were then sequenced for DNA and RNA, the genetic blueprints and messenger of life. This enabled us to know what viruses are in a given environment and what potential hosts are also present. Said Stephen Harris Bronso, an associate professor in the University of Ottawa biology department, who lead the work. But to find out how likely they were to jump host, the team needed to examine the equivalent of each virus and host family tree. Basically, what we try to do is measure how similar these trees are, said Andre Levinson, first author of the research. Similarly, genealogists suggest a virus has evolved along with the host, but differences suggest spillover, and if a virus has jumped host once, it is more likely to do so again. Very unpredictable. The analysis found pronounced differences between virus and host in the lake bed, which is directly correlated to the risk of spillover, said Addis Brosso. The difference was less stark in the riverbeds, which the researcher theories is because water erodes the topsoil, removing organisms and limiting interaction between viruses and potential new hosts. Those instead wash into the lake, which has seen dramatic change in recent years. The study says has increased water from melting glaciers deposits more sediment. That's going to bring together hosts and viruses that would not normally encounter each other, Lemon said, the author of the research published in the Proceedings of the Royal Society B Biological Sciences Journal. Caution they are neither forecasting an actual spillover nor a pandemic. The likelihood of dramatic events remain very low, Lemon said. They also warn more work is needed to clarify how big the differences between viruses and hosts needs to be create serious spillover risk. But they argue that warming weather could increase risk fact further if a new potential host move into previously inhospitable regions. It could be anything from ticks to mosquitoes to certain animal to bacteria and viruses themselves, said Lemlius. It's really unpredictable, and the effect of spillover itself is very unpredictable. It can range from Benjamin to an actual pandemic. The team wants more research and surveillance work in the region to understand the risk. Obviously, we have seen in the past 2 years what the effects of spillover can be, said Limnans. Moving on towards next topic, astronomers create new technique to assist in search for dark matter, meteors, may help astronomers devise a new way to locate dark matter, mysterious and invincible particles that have so far only been described by the effect they have on the natural world, 5 times more prevalent than ordinary matter. Dark matter makes up about 85% of the total mass of the universe and about a quarter, 26.8% of the universe's total mass and energy. Humans are unable to detect this elusive particle directly as dark matter emits no light, so scientists use powerful instruments like the Hubble Space Telescope or NASA upcoming Nancy Grace Roman Space Telescope to witness its influence on galaxies and other distant star clusters. Now, according to a study led by researchers at the Ohio State University, radar system on the ground could be used to aid the search. John Beckham, co-author of the study and a professor of the physics astronomy at Ohio State, said that while scientists typically look only for tiny particles of dark matter with small masses, the goal of this new research is to improve the search by helping to characterize microscopic dark matter particles with a large mass that might not reach traditional terrestrial detectors. One of the reasons dark matter is so hard to detect could be because the particles are so massive, become said. If the dark matter mass is small, then the particles are common, but if the mass is large, the particles are rare. Though these particles can't be touched or seen, dark matter can be perceived by its gravitational effects on other celestial phenomena like stars or black holes, while its effects on the natural system aren't easy to characterize. Taking the time to learn more about dark matter opens up new avenues for scientists to understand the size, shape, and the future of the cosmos. Becomes said. Such detection can also reveal the mass of these particles, which, depending on their size, can have huge effects on the formation and structure of the galaxy. The researcher is currently published on the open access preprint server arXiv. What makes the research so novel is that scientists applied the same technology that is used to track meteors as they streak across the sky when passing through Earth's atmosphere. Both meteors and dark matter particles produce ionization deposits, a form of radiation that leaves behind free electrons, atoms capable of conducting electricity. Electromagnetic waves released by radar bounce off the free electrons, signaling the presence of otherworldly matter, which can then be used to distinguish dark matter from meteors. In this way, the entire planet atmosphere can be transformed into one efficient large scale particle detector. Although scientists have used this method of meteor hunting for decades, Becom said he was surprised that nobody had ever applied this system or the previously collected data in the search for dark matter. One of the study's most significant conclusions in how the team new method could complement other cosmological searches for dark matter as their system offers a new level of accuracy and sensitivity many other techniques lag. Current cosmology techniques are pretty sensitive, but they don't have a way to check their own work. Become said, this is a totally new technique, so if scientists are unsure about what they have detected, a signal from cosmology could be checked in detail with the radar technique. Co-authors were Pavan Dakkal, Stephen Prohera, and Christopher Capillo of Ohio State, as well as Scott Palo and John Marino of the University of Colorado Boulder. I mean, great for astronomers and for the universe, of course. So, yep. Moving on to our next topic. Scientists discover mechanism that can cause collapse of great Atlantic circulation system. The Atlantic Meridional Overturning Circulation AMOC, a system of ocean current that carry warm water from the tropics into North Atlantic and transport cold water from the northern to the southern hemisphere, is a fundamental mechanism for the regulation of Earth climate. The conveyor belt has collapsed in the past, owing to natural factor. The most recent collapse played a key role in the last deglaciation. AMOC is now threatened by global warming. Scientists have shown that a new study has discovered the sequence of past breakdown events. The study was conducted by German researcher and Brazilian paleo- paleoclimatologist Cristiana Mazur Chiesa, a professor at the University of Sao Paulo School of Arts, Science and Humanities, each USP in Brazil. An article reporting their findings is published in Nature Communication. An investigation of marine sediments collected between Canada and Greenland led to the discovery that in the past glacier covering the terrestrials that now correspond to Canada and the northern United States released colossal number of icebergs into the Atlantic owing to ocean surface warming in the region, Jesse told Agencia Fepes. The icebergs melted in the ocean and deposited continent, continental sediments on the seabed. Identification of the sediments and reconstitution of the subsurface temperature in the region enabled scientists to establish for the first time and subsurface warming preceded to the mass iceberg release, he said. The enormous volume of fresh water added by melting of the iceberg modified the composition of the ocean of high latitudes of the northern hemisphere. This had a tremendous impact on the global climate because the region between Canada and Greenland is a particularly sensitive part of Amos. This gigantic conveyor belt carries lighter, warmer surface water from the South Atlantic to the North Atlantic. At higher latitudes of the North Atlantic, the surface water releases heat into the cold atmosphere, becoming heavier and sinking down the water column. The deeper, colder, and denser water then flows southward again until it reaches the vicinity of Antarctica, where it returns to the surface, forced by an intense upwelling on the surface. It warms up, loses loses density, and the completes the circulation. Chisse said. Amok does not only transport a huge volume of water amounting to some 18 million cubic meter per second, it also conveys massive amount of energy equivalent to about 100,000 times the power generated by Itaipu, and the world's second largest hydroelectric plant on the Brazil Paraguay border. The spatial distribution of this energy influences the climate in several parts of the planet, including Brazil. Vigorous circulation maintains the climate as we know it, while its collapse causes a pronounced redistribution of energy, altering the climate. Among collapsed several times during the last glacial period between the 71,000 and 12,000 years below the present BP. Our other study led by Chessy and based on on an analysis of marine sediment collected between the coast of Venezuela and northeast Brazil showed that these collapses caused a torrential increase in rainfall in northeast Brazil and a sharp drop in rainfall in Venezuela in the far north of Amazon. Decreasing rainfall has also been described in the topological area of North Africa and Asia. By discovering that North Atlantic subsurface warming at higher latitude preceded massive releases of iceberg from Canada and the US into the Atlantic, researchers were able to establish the sequence of events responsible for the collapse of AMOC. The process began with an apparently insignificant weakening of AMOC, which causes subsurface warming at higher latitudes of the North Atlantic. This warming melts of the glacier sea snowds, moving the glacier rapidly seaward and releasing colossal armades of the iceberg. As the icebergs melt, subsurface water salinity decreases in the region. The surface water isn't dense enough to sink and AMOC collapses, Chisi said. Monitoring of AMOC in recent decades shows that it is weakening. There are three main reasons. intensification of rainfall at high latitudes of the North Atlantic, melting of the ice cap over Greenland, and warming of the planet surface. All three causes are associated with the rising levels of greenhouse gases in the atmosphere due to human activity. This latest discovery suggests the weaker AMOC will cause anomalous subsurface warming at high latitudes of the North Atlantic, which will melt glacial sea notes in Greenland. Ultimately, this could lead to AMOC to collapse, exor- exor- exacerbating the climate crisis with major repercussions. I mean, okay. Moving on to our next topic. Simulations show major forest fires can increase intensity of distant storms. A team of researchers with members from the Pacific Northwest National Laboratory, the University of Oklahoma, and the California Institute of Technology has found while simulation the major forest fires in western parts of the United States can increase the intensity of thunderstorms hundreds or even thousands of miles downwind. The study is published in the Proceeding of the National Academy of Science. Prior research has shown that wildfires or forest fires can have major impact on local weather system. Heat and soot can lead to the formation of major thunderstorm in this near field. The researcher found evidence of a similar phenomenon involving downside system far away from the fire. To learn more about large-scale weather impacts of forest fires, the researcher pored over weather data for the continental U.S. for the years 2010 to 2020. They looked for major storm events that occurred not long after or during major fire in the West. The researcher found several examples of major storm uh, breaking out other major fires, but they also note that fire season in the west does not coincide with storm season further east. Thus, the impact of the fires as the storm is difficult to associate. To gain a better understanding of what may occur during other major fires, the researcher turned to an established weather model that allowed for adjusting parameters such as heat and smoke to observe the impacts. The simulation showed that big fire can increase the intensity of storm in system hundreds or even thousands of miles away. The researcher also found that they can contribute to creation of larger hailstones. More specifically, the simulation showed that large fires can increase air flowing across the continent, pushing moist air ahead of it. That can lead to increasing storm strength. And the simulation also showed that the soot from a big fire can be carried for long distances, contributing to increase in hail size. The researchers sum up by suggesting that global warming, which is making western parts of the US both hotter and drier, is likely to lead to bigger and stronger storms across the US due to, in part, to the impact of the increase in forest fires. Okay. Moving on towards next topic, researcher developed system to test brain ultrasound treatment in mice. Hmm. Non-invasive brain ultrasound treatment represent a promising alternative to other brain stimulation modalities and pharmaceutical drugs. However, testing it can be challenging due to a lack of preclinical system for chronic simulation in awake animals. As described in research published in Advanced Science, investigator recent developed a system to deliver ultrasound simulation to the brain in awake, naturally behaving mice. The team used the system to evaluate the effects of ultrasound and neuromodulation on sleep and working memory. The advance will also help other scientists test different ultrasound treatment protocols in mouse models of diverse neurological conditions. Ultrasound is an exciting modality of neuromodulation because of its non-invasive nature. There is a high potential for using ultrasound to treat brain disorders, said corresponding author Hyunjo J. Lee, PhD of Korea Advanced Institute of Science and Technology. I hope our system can help many neuroscientists to explore the therapeutic potential of ultrasound simulation in the future. Moving on to our next topic. The vulnerability of transformer based malware detectors to adversarial attacks. Hmm. Cyber attackers are coming with increasing sophisticated techniques to steal user sensitive information, encrypt documents, of course, to receive a ransom or damage computer system. As a result, computer scientists have been trying to create more effective techniques to detect and prevent cyber attacks. Many of the malware detectors developed in the recent years are based on machine learning algorithms trained to automatically recognize the patterns or signatures associated with the specific cyber attacks. While some of these algorithms achieved remarkable results, they are typically susceptible to adverse attacks. Adversarial attacks occur when a malicious user perturbs or edits data in subtle ways to ensure that it is misclassified by a machine learning algorithm. As a result of the subtle permutation, the algorithm might classify malware as if it were safe and regular software. Researchers at the College of Engineering, Pune, India, have recently carried out a study investigating the vulnerability of deep learning based malware detected to adversarial attacks. The paper pre published on RZIV specifically focuses on a detector based on transformer, a class of deep learning model that can weigh different parts of input data differently. Many machine learning based models have been proposed to efficiently detect a wide variety of malware. Yash Jaghotia, Harem Patel, and Jugal Ronlani wrote in their paper, many of these models are found to be susceptible to adversely attack that works by generating intentionally designed input that can force this model to misclassify work aims to explore vulnerabilities in the current state of the art malware detector to adversarial attacks. To access the vulnerability of deep learning based malware detector to adversarial attack, Jakotia Patel and Ravlani developed their own malware detection system. This system has three key component: an assembly module, a static feature module, and a neural network module. The assembly module is responsible for calculating assembly language features and data later used to classify data using the same input fed to the assembly module. The static feature module produces two sets of vectors that will also used by to classify data. The neural network model uses the feature and the vector produced by the two models to classify files and software. Ultimately, its goal is to determine whether the files and software it analysis are benign or malicious. The researcher tested the transformer based malware detector in a series of tests where they assessed how its performance was affected by adverse attacks. They found that it was prone to misclassifying data almost 1 in 4 times. We trained a transformer based malware detector carried out adversely attack, resulting in misclassification rate of 23.9%. Proposed a defense that reduced this misclassification rate to half. Jakarta Patel and Ravlani wrote in the paper, the recent findings gathered by this team of researchers highlight the vulnerability of current transformer-based malware detectors to adversely attack based on the observation. Jakarta, Part, and Ravlani thus propose a series of defense strategies that could help to increase the resilience of transformer trained to detect malware against adversarial attacks. These strategies include training the algorithm and adversarial samples, masking a model gradient, reducing the number of features that the algorithm look at, and blocking the so-called transferability of neural architecture in the future. This strategy and the overall findings published in the recent paper could inform the developmental of more effective and reliable deep learning based malware detectors. Okay. Moving on towards next topic, the most precise accounting yet of dark energy and dark matter. Astrophysicists have performed a powerful new analysis that places the most precise limits yet on the composition and evolution of the universe. With this analysis, dubbed Pantheon, cosmologists find themselves at a crossroads. Pantheon convincingly finds that the cosmos is composed of about two-thirds dark energy and one-third matter, mostly in the form of dark matter, and it is expanding at an accelerating pace over the last several billion years. However, Pantheon also cements a major disagreements over the pace of the expansion that has yet to be solved. By putting prevailing modern cosmological theories known as standard model of cosmology on even firmer inventory and statistically footing Pantheon further closer to door, an alternate framework accounting for dark energy and dark matter. Both are bedrocks of the standard model of cosmology, but have yet to be directly detected and rank among the model biggest mysteries. Following through on the result of Pantheon, researcher can now pursue more precise observational tests and hone explanation for the ostensible cosmos. With the Pantheon Plus result, we are able to put the most precise constraints on the dynamics and history of the universe to date, says Dylan Broad, an Einstein Fellow at the Center of Astrophysics, Harvard, and Simpson. We have combed over the data and can now say with more confidence than ever before how the universe has evolved over the eons, and that the current best theories for dark energy and dark matter hold strong. Broad is the lead author of a series of papers describing the new Pantheon analysis published jointly today in a special issue of the Astrophysical Journal. Pantheon is based on the larger datasets of its kind, comprising more than 1500 stellar explosions called type La supernova. This bright blast occurred when white dwarf stars, remnant of stars like our sun, accumulate too much mass and undergo a runaway thermonuclear reaction. Because type layer supernova outshine entire galaxies, the stellar detonations can be glimpsed at distance exceeding 10 billion light years or back through about three quarters of the universal total age. Given that the supernova blaze with nearly uniform intrinsic brightness, scientists can use the explosion apparent brightness, which diminish with distance, along with redshift measurements as marker of time and space. That information in turn reveals how fast the universe expands during different epochs, which is then used to test theories of the fundamental component of the universe. The breakthrough discovery in 1998 of the universe accelerating growth was thanks to a study of type Ia supernova. In this manner, scientists attribute the expansion to an invincible energy, therefore monitored dark energy inherent to the fabric of the universe itself. Subsequent decades of work have continued to compile ever larger dataset revealing supernova across an even wider range of space and time. Pantheon has now brought them together into the most statistically robust analysis to date. In many ways, this latest Pantheon analysis is a culmination of more than 2 decades worth of diligent efforts by observers and theorists worldwide in deciphering the essence of the cosmos, says Adam Rees, one of the winners of the 211 Nobel Prize in Physics for the discovery of the accelerating expansion of the universe, and Bloomberg Distinguished Professor at Johns Hopkins University JHU and the Space Telescope Science Institute in the Baltimore, Maryland. Rees is also an alum of Harvard University, holding a PhD in astrophysics. Broad's own career in cosmology traces back to its undergraduate years at JHU, where he has taught and advised. By Rees, their board worked with a PhD student and raised advice. Dan Skondek, which is now an assistant professor of physics at Duke University, and another co-authored on uh, on the new series of papers. Several years ago, Skondek developed the original Pantheon analysis of approximately 1000 supernova. Now, Broad and Skondek and their new Pantheon team have added some 50% more supernova data points in Pantheon, coupled with the improvement in analysis techniques and addressing potential source of error, which ultimately has yielded twice the precision of the original Pantheon. This leap in both the dataset quality and in our understanding of the physics that underpin it would not have been possible without a stellar team of student and collaborator working diligently to improve every facet of the analysis, says Broad. Taking the data as a whole, the new analysis hold that 66.2% of the universe manifests as dark energy, with the remaining 33.8% being a combination of dark matter and matter. To arrive at even more comprehensive understanding of the constituent components of the universe at different epochs, Broad and colleagues combined pantheism with the other strongly evidenced independent and complementary measure of the large scale structure of the universe, with measurement from the earliest light in the universe, the cosmic microwave background. Another way pantheon result relates to one of the paramount goals of modern cosmology, nailing down the current expansion rate of the universe, known as the Hubble constant. Pooling and the Pantheon sample with data from the Shoes supernova HO for the equation of state collaboration led by Rees results in the most stringent local measurement of the current expansion rate of the universe. Pantheon and Shoes together find a Hubble constant of 73.4 km per second per megaparsec, with only 1.3 uncertainly stated. Another way for every mega per parsec, or 3.26 million light years. The analysis estimates that in the nearby universe, space itself expanding at more than 1600 miles per hour. However, observations from an entirely different epoch of the universe history predict a different story. Measurement of the universe earliest light, the cosmic microwave background, when combined with the current standard model of cosmology, constantly peg the Hubble constant at a rate that is significant less than observation taken via type La supernova and other astrophysical markers. This sizable disparity between the two methodologies has been termed the Hubble tension. The new Pantheon shows datasets heighten this Hubble tension. In fact, the tension has now passed the important fifth sigma threshold, about 1 in a million odds of arising due to random chance that physicists used to distinguish between possible statistically flukes and something that must accordingly be understood. Reaching this new statistically level highlights the challenge of both theorists and astrophysicists to try to explain Hubble constant disparity. We thought it would be possible to find clues to a novel solution to the platforms to these problems in our dataset, but instead we are finding that our data rules out many of these options, that the profound disparity remain as stubborn as ever, says Brout. The Pantheon result could help point to where the solution to the Hubble tension lies. Many recent theories have begun pointing to exotic new physics in the very early universe. However, such unverified theories must withstand the scientific process, and the Hubble tension continues to be a major challenge, says Brout. Overall, Pantheon offers scientists a comprehensive look back through much of cosmic history. The earliest, most distant supernova in the dataset gleam forth from 10.7 billion light years away, meaning from when the universe was roughly a quarter of its current age. In that earlier era, dark matter and its associated gravity held the universe expansion rate in check. Such rate of affairs changed dramatically over the next several billion years as the influence of dark energy overwhelmed that of dark matter. Dark energy has since flung the contents of the cosmos ever further apart and at an even increasing rate. With this combined pantheon dataset, we get a precise view of the universe from the time when it was dominated by dark matter to when the universe became dominated by dark energy, says Broad. This dataset is a uniquely opportunity to see dark energy turn on and drive the evolution of the cosmos on the grandest scales of through present time. Studying this changeover now with even stronger statistically evidence will hopefully lead to new insight into dark energy enigmatic nature. Pantheon is giving us our best chance to data of constraining dark energy, its origin and its evolution, says Brout. Okay, so I mean, this is the last article of the day of the podcast, and as I previously discussed that we have started a newsletter providing you the information about that is not easily available on the surface web. So if you are interested in that kind of information, please subscribe to this newsletter. And yes, because I mean, many are writers being constantly writing those articles, and without having no subscribers, it's not going to be seen or anything. So, if you are to sustain this business model, please subscribe to this newsletter. And yes, due to this only, we are not able to provide you the more effective news or more effective content. So please, it's a request to you guys. Otherwise, it's your choice, of course. At the end, I just wanna say, you guys, keep learning, stay curious, stay healthy.